Dear students, through this video, we'll learn about inventory models. In a practical situation, with the help of the demand pattern, we can classify the inventory model as the four types. One is an deterministic model with constant time, that is static time. Same deterministic model, but variable time, dynamic time, that time must be changed. Probabilistic model with the stationary over time, and probabilistic model non-stationary with over time. These are the four models. For your syllabus, we are having a deterministic model with the static time. We'll learn now the static economic order quantity models. We are calling that one as static economic order quantity models or fixed order quantity models. The fixed order quantity models are economic order quantity model. We are denoting that one as EOQ, and economic production quantity model EPQ. It's also called production order quantity model, that is POQ. Finally, we can learn about the quantity discount model QD. First, I will explain the economic order quantity model. It is also known as a classical model in inventory control. It has several cases. The first case, I assume EOQ problem without shortage with uniform demand. For this model, we need the following assumption. First one is the demand D is uniform. That means, so whenever you are calculating for inventory control, it is for year only. For our frame or for our factory, we need how much raw material is needed for the certain unit time period. That's why we are assumed as demand is known. And lead time is 0. We know that the lead time is a time between the placing of order and receiving of order. If the lead time is 0 means whenever you are placing of order, so at the time itself we received the order. That is the meaning. The production rate is infinite. That is, there is no disturbance in the production. It's going on smoothly and shortages are not allowed. These are all assumption of our economic order quantity model. Now, we'll go for the notations. We are denoting Q is a lot size of each production run. For a production, we are making an order of quantity Q. D denotes the total number of units demand per unit time period. We are considering unit time period as an year. C denotes cost of our product, that is cost of our raw material. I denotes inventory carrying cost percentage. C1 denotes the holding or carrying cost per unit for a time period. C1 can be calculated with the help of C into I. For example, cost of unit must be 75 rupees. So rupees 75 per kg. And the inventory cost carrying cost must be 10% of the corresponding cost value. So then the holding cost value should be calculated. The holding cost value C1 should be calculated with help of C1 into I. That's nothing. 75 into the 10%. So that is equivalent to 7.5 rupees. Rupees 7.5. Rupees 7.5. In this way, we can calculate holding cost if the inventory carrying cost percentage. CS denotes the setup cost for production run. The setup cost must be the cost due to the order. It's happened only while ordering the unit. This model requires two types of parameters only, because the total demands per unit time period is fixed. The total time therefore, our fine always having a demand is same. So it doesn't depends inventory cost. It doesn't affect inventory cost level. If you are having demand must be vary, then only you have to include that one. So, and one more thing, shortage is also not allowed here. For shortage cost and purchase cost should be omitted. We need of the setup cost and also holding cost. I will explain our EOQ model through this graph. Imagine in the initial stage we are placing our order Q quantity, and after we are started consuming, and gradually our raw material is decreasing, and at certain stage our raw material is 0. So then we are placing the same quantity again, and we are started to consume, and this process is going on until the total time period should be elapsed. That is, our demand value should be fulfilled. The time period between placing a first order and the second order is called a cycle. This is a time period of a cycle, and it is one cycle. Especially, we are calling this one as first cycle. Now we are in need of the two types of cost. One cost is in setup cost, and one more cost is in holding cost. To find holding cost, I want to know how much quantity I am holding in a cycle. So that must be calculated with the help of average inventory level. Average inventory level should be calculated with the help of this formula, that is 1 by 2 into the maximum level plus minimum level divided by 2. Note that we are ordering the maximum quantity level is Q and the minimum quantity level is 0. So therefore, Q plus 0 divided by 2, that is we are having Q by 2. Or otherwise, we can use the inventory we are using is looking like this triangle. So if you are finding the area of this triangle, then we got the idea. Actually, this time period is in one cycle. So therefore, the area of the triangle is denoted as of B into H. The formula of BH is the B denotes the breadth and H denotes the height. The breadth of this one is in one time period. We can place instead of B 1, and the height of that one is in Q quantity. Therefore, the average inventory becomes the Q by 2. We calculated the average inventory. Then we can go for the carrying cost, that is holding cost. To find the carrying cost, we have to know the average number of units of inventory and the cost of one unit and inventory carrying cost percentage. That is, the average number of units of inventory is calculated here, that is Q divided by 2. I placed Q divided by 2 here, and the cost of unit is C, and the inventory carrying percentage is I, and it will be multiplied. So therefore, you are getting Q divided by 2 into CI. Actually, already I explained the CI can be written in the form of C1. C1 denotes the cost of carrying and inventory and unit time. So finally, we calculated our carrying cost must be Q by 2 into C1. Ordering cost. Next one is we need of ordering cost. Ordering cost is number of orders per year into order cost for the cycle. I already told for an order we need of amount CS as an ordering cost. But I want to know how many orders I want to place. So in this model, a total demand must be D, and each time I am placing of order quantity Q and so on. The final total demand must be fulfilled if you are adding all the Q values. So this is the number of times order. Number of times order. The number of times order is denoted as, if I am denoting this number of time order as N, then we can write this one as N times of Q. Then we can calculate the number of orders N is nothing but D divided by Q. So number of orders in that 1 year period is D by Q. And for each order, I am spending of amount of CS amount as ordering cost. Therefore, total ordering cost is D by Q into CS. That's all, students. We find that carrying cost and also ordering cost. I already told shortage is not allowed here and demand is fixed. So that's why we are not bothering about that two cost. So the total inventory cost should be involving two types of cost. One is carrying cost and also ordering cost. That should be added. That is, you are having Q by 2 into C1 divided by, Q by 2 into C1 and D by Q into CS. This is total inventory cost. But our aim is we want to minimize the inventory cost. If we want to find the maximum or minimum of a function f of x, we have to differentiate the f of x with respect to x and we can equate equal to 0. In the same manner, to find the minimum value of a function, we have to differentiate our function with respect to the variable and we have to equate that one equal to 0. So therefore, I am differentiating our function with respect to q, that is our function is c of q, and I am planning to equate that one equal to 0. If you are doing like that, the differentiation of this term with respect to q is 1 by 2 and q differentiation is 1 and c1 is in constant as it is and plus d is constant and cs is constant. The differentiation of 1 by q is minus 1 divided by q square. It is equal to 0. I am equating that one equal to 0. If you are equating like this, we are getting 1 by 2 into c1, it is equal to, this term should be carried on the other side, then we are getting dcs divided by q square. Thus, we are getting a q square value is equal to 2 times of dcs divided by 2. Finally, we got a minimum order level. The minimum order level should be happen if you are having q value is looking like this, a square root of, it is c1, a square root of 2 dcs divided by c1. This is called economic order quantity level. That is the optimum the inventory cost obtained whenever you are ordering in the level of q quantity, that is equal to 2 CSD divided by C1. This is known as the economic optimum lot size formula. The above formula also can be written as, instead of C1, we can use the inventory carrying cost percentage. The inventory carrying cost percentage C1 should be written in the form of inventory carrying cost percentage CA. So therefore, we can replace instead of C1 as into I also. This is economic order quantity level, but we need of the minimum total annual inventory cost. Already we calculated inventory cost. The total inventory cost is given in the equation 1. The equation in that equation 1, I am substituting our economic order quantity Q value. The Q value should be replaced as Q is equal to square root of 2 CSD divided by C1 like this. So if you are replacing, I am replacing instead of Q as Q star. If you replaced that quantity, I am substituted here instead of Q as square root of 2CD divided by C1. And here also I am substituting a square root of 2CD. That is 1 by Q can be replaced as looking like this. Now, we can cancel this one as 1 by 2 and square root of 2 CSD divided by C1. It is square root of 2 CSD divided by root C1. Okay. You can write this C1 as root C1 into root C1 and plus DCS can be written in the form of square root of DCS into square root of DCS and it is multiplied with square root of C1 divided by square root of 2 into square root of CSD. Now you can cancel one DCS and one DCS here, and the same way you can cancel this too. So what is the remaining value you are getting here means the remaining value is 1 divided by, you can write this root 2 is cancelled with this one and the remaining is root 2. Therefore, we are getting a square root of CSD divided by root 2 and into C1 plus square root of TCS into C1 divided by root 2. I am getting 2 times of this one. So therefore 2 times of square root of DC1CS divided by square root of 2, and this should be cancelled and we are getting root 2. So finally we are getting answer 2DC1CS. This must be the minimum total annual inventory cost. The minimum total annual inventory cost can be written in the form of 2C1CSD to square root. In a similar way, we can find the optimum length time in between orders. The optimum length time in between orders should be denoted as T0. It is equal to economic order quantity divided by demand rate. We know economic order quantity is Q star, or that is Q dot, and it is divided with the demand rate D. And this is a formula for optimum ordering time interval. The number of orders already we know the number of orders N is denoted by the total demand divided by Q, that is the Q is here economic order quantity. Now we'll just recollect all the ideas in a remark. In this model, with shortage and with uniform demand, economic order quantity Q star or Q dot can be written in the form of these two formulas. And the minimum annual inventory cost is this one. The time period of ordering interval is equal to Q divided by D, and the number of order is D by Q, and total inventory cost becomes this one. Especially it is Q star or Q dot. It is Q star. Now we will move further. Yeah, aircraft company uses rebates at approximate customer rate of 2,500 kgs per year. Each unit cost rupees 50 per kg, and the company personnel estimate that it cost of rupees 130 to place an order, and the carrying cost of the inventory is 10% per year. How frequently should orders for rebate be placed? Also determine the optimum size of each order. In this problem, we have to know the demand value. The demand value is given in the first line. The aircraft company uses the rebate of approximate customer rate of 2,500 per kg. So therefore, the D denotes 2,500, and each cost of 30 rupees per kg. The company personnel estimate the cost 130 and a place of order. So while placing order, they are spending 130 amount. Therefore, the cost of setup, that is the cost of order, is 130 per order. And next we need of holding cost. They are spending of money of 10% in the carrying cost as a carrying cost in the cost value. So therefore, the 10% denote here, the value of I denotes 10%, and the cost of each unit is 30 rupees. So therefore, the C1 is nothing but C into I. That is a formula. With help of that one, we can find the cost of carrying cost for 1 unit is 3 rupees. How frequently should order be placed? Okay, that means they are in need of the time period of order T. T should be calculated with help of, just look the formula what you have. The T is nothing but Q divided by D. Q divided by D. So therefore, we are in need of the economic order quantity Q and demand rate D. So, and determine optimum size of each order. That optimum size of each order is nothing but Q. So the formula for Q is nothing but square root of 2DCS divided by C1, and all the data you are having 2, and the D value is 2,500, and CS value, the setup cost must be 130 divided by 3. This gives the answer of 465.47 units. The time period is Q by D as I told earlier. This should be calculated by substituting the Q value 465.47 divided by 2500. It is equal to 0.186 here. So if you are calculating that one in the term of months, you have to multiply this one into 12. If you are multiplying this one into 12, we are getting 2.23 months. The 2.23 months is a time period of order, each order, and the number of orders is denoted as D by Q, and the D by Q is nothing but, that is, it is a reciprocal of time period. It is 5.37 orders per minute. Thank you, student.